Okay, so this is regular lesson 3, symmetry and surface area. So by the end of this lesson, we are going to understand how to find the surface area of composite 3D objects. And we want to know this skill so that way we can solve problems. And so what we're going to go over in this lesson is basic surface area of a rectangular prism and a cylinder. And then we're going to go over what would happen if you started combining shapes and finding the surface area of those composite shapes. If you have not watched lesson 3A or lesson 4A, it might be beneficial to you, especially if you're not sure about nets or about finding just the area of a rectangle or triangle or circle. Give them a quick watch as a refresher. So we are looking at a prism, and I want to show you a 3D model site that I found that I think is pretty helpful. So if you look, I literally just Googled 3D interactive prisms, and this is the first site that came up, and I thought it was pretty good. So I clicked on rectangular prism, and so we have a rectangular prism, and it's turning around in space. It's 3D, okay? And on the side here, you can see the net being built and unbuilt. And so I'm just going to So see, there it builds up, and then it's going to fold down. I'm just going to pause it. So we have the top and the bottom. So the same shape repeated twice. We have the front and the back, the same shape repeated twice. And the left side and the right side. So the same shape repeated twice. Okay, this thing, if it's not making you dizzy yet, I don't know what would. So when we go back to do our calculation, I want you to keep this in mind, this net in mind, and this 3D shape. It might be handy for you to grab something like a Kleenex box or something else that you have around your house that's a rectangular prism, just to keep in mind what it looks like. So let's go back to, here we go. So when we're looking at this rectangular prism, I tell you that one side has a length of 2 centimeters, the front side has a length of 3 centimeters, and the whole prism has a height of 6 centimeters. And so I want you either to draw out the net or draw out the different faces. I prefer the faces method, but this may not work for you. So this is the front. And we said that the front and the back are replicates. So we have this shape twice, and this is 3 centimeters by a height of 6 centimeters. Then I'm going to draw out the side. So the side is also a rectangle, but the bottom width is 2 centimeters and the height is 6 centimeters. So this is the left side, but we also said that the right side would be the same. So this is going to be times 2. And then lastly, there is the top and bottom, which is more square-like, but also a rectangle because one side is 2 centimeters and the other side is 3 centimeters. And so this is the top, but the bottom would be the exact same. So this is again times 2. So that's kind of our first step, is just dealing with looking at which 2D surfaces are we looking at. Remember, surface area deals with 2D area, not volume. Yes, we are dealing with 3-dimensional shapes, but the measurements themselves are 2-dimensional. So we think of, okay, well, we have a rectangle. How do we find area of a rectangle? If you haven't completed your cheat sheet yet, might be a good idea to do so, so that way you have all of these formulas at your hand if you don't remember them. So anyways, to find the area of this rectangle, we're going to go length times width. We could also go base times height. It doesn't really matter. And we're going to times it by 2 because there are 2 of this shape. Same thing when we look at the left and right side. Again, we have a rectangle, so length times width, and we're going to times it by 2. And lastly, the same for the top and bottom. They are rectangle, so length times width times 2. So in order to find the surface area, I'm going to find the area of the front and back plus the area of the left and right sides plus the area of the top and bottom. In previous years, we would have found each of these separately and then added them together. You are grade 9s. I think you can handle this, so we're going to write it out all together. So surface area equals 2 times the length times the width of our front back, plus 2 times the length times the width of the 2 sides, plus 2 times the length and width of the top and bottom. And I've color-coded it to kind of help us keep track of what's going on here, because this can get confusing pretty quickly. So we're going to go 2 times 3 centimeters times 6 centimeters plus 2 times 2 centimeters times 6 centimeters plus 2 times 2 centimeters times 3 centimeters. Keeping in mind your order of operations, any multiplication needs to happen before any addition happens, and we need to solve brackets before anything else. But hopefully you notice this is just, these 2's are just more multiplication. So I can actually do all of this at once, followed by all of this, and all of that. Okay. So when we multiply these out, we should get 36 centimeters squared plus 24 centimeters squared plus 12 centimeters squared. Now we can add them all up, and notice that our units are all the same. We can only combine them if the units are the same, so that's important to note. And you get a total surface area of 72 centimeters squared. Yes, I know it's a lot of work, but that's kind of what we have to do. The other way we could do it is we could notice that every single shape got doubled. So we could say we're going to find the area of the front, one side, plus the area of the left side, plus the area of the top, and we're going to double that to find the full surface area. Okay, and so that would look something like this. So surface area equals 2 times 3 centimeters times 6 centimeters plus 2 centimeters times 6 centimeters plus 2 centimeters times 3 centimeters. Okay, and then you would get 2 times, following our order of operations, multiplying needs to happen before adding does. So 18 centimeters squared plus 12 centimeters squared plus 6 centimeters squared. Again, everything following order of operations. Anything inside the brackets must be done first, so the adding must happen before I can multiply by my coefficient. So we get 2 times 36 centimeters squared. Now we can multiply, again, 72 centimeters squared. So either way, we get the same result. Kind of whatever makes most sense to you is the method that you should follow. Our next example is of a cylinder. And so I'm going to go back to that interactive, and we're going to look at a cylinder. Okay, so we're still on the same website, but now we clicked on for cylinders, and so actually it kind of describes how the surface area of a cylinder how the formula came to be. So basically, if we take a cylinder and you think of like if you had a can and you rip the label off, if you take the label off, you're going to get a rectangle. And if you cut the can open, at the top you would have a circle, and at the bottom you would have a circle. So basically, when we're talking about a cylinder, we're talking about the area of 2 circles plus the area of a rectangle. Now, something kind of cool, and if you watch this, you'll see. So, okay, and so what we've done is we've unrolled that rectangle, and I hope you noticed that the length of that rectangle, that pink line, is the same as the length around the outside of a circle, or the circumference of a circle. And so it even says here, the length of the rectangle is equal to the circumference of the circular base. And the way that we find circumference is 2 times pi times radius, or pi times diameter. Either one, it doesn't matter to me which one you use. Okay, so then if we continue, oh, just kidding, that's all it shows. And so if you continue on this site and you keep clicking, you will actually get a couple examples where you could try practicing finding the circumference of a cylinder if it's something that you struggle with. I will add this website to our links on D2L so that you can check it out as well, because I think it's pretty helpful for you. Okay, so back to our cylinder example. So we said in order to find the surface area of a cylinder, we need to find the area of 2 circles plus the area of a rectangle. So we have a circle, and we're going to have 2 of them, and then we have a rectangle. Please notice that my drawings are not to scale, and no, I have not been using a ruler. This length we said is the same as the circumference of a circle, and the way that we find circumference of a circle is either 2 times pi times radius, or pi times the diameter of the circle, because 2 times the radius is the same as the diameter. And we have just one of these shapes. The important information on our circle that we need to know is the radius, and on this circle the radius is 2 centimeters. On our rectangular prism, to find this length, we're going to go 2 times pi times radius, so 2 times 2 times 3.14, and when we do that, we get the length of the side. And so since pi is not a rational number, it is a non-repeating, non-terminating decimal, we end up getting our answer for the length of the rectangle to be a irrational number as well. So we're going to round it to 2 decimal places, and so we get 12.57 centimeters. And the other length is actually the height of the cylinder. So 8 centimeters is the height of this rectangle. So now we need to find the area. Area of a circle is pi r squared, or pi times radius, and we have 2 of these. So we're going to go 2 times pi times radius, and we're dealing with a rectangle, so area is equal to length times width. Okay, or area equals length, which is 2 times pi times radius, times the width or the height of the prism. Okay, height or width, whatever you want to call it. So this is actually on one of your formula sheets for surface area. This is one of the ones that we give you, and the formula that you get says surface area equals 2 pi r squared, so for your circles, plus pi times diameter times height. Or you might see this one, surface area equals 2 pi r squared plus 2 pi r h. Again, exactly the same thing. I tend to like the first version of this one just because it has diameter in it, and that's nice and easy to use. A little bit less calculation, doesn't really matter to me. So we just fill in 2 pi times 2 centimeters squared plus pi times diameter, which is 4 centimeters, times the height of the cylinder, which is 8 centimeters. Following our order of operations, we are going to complete our exponents before we do anything else. So we get 2 pi times 4 centimeters squared plus pi times 4 centimeters times 8 centimeters. Again, following our operations, we're going to do any multiplying before we do any adding. So, and I'm taking 2 decimal places on all of these answers. So 2 times pi times 4 gives us 25.13 centimeters squared plus 100.53 centimeters squared. Lastly, we can add these up. and we get 125.66 centimeters squared. And these questions don't tell us what kind of decimal places to use, but that's what we're going to use. So these first two examples have taken us a bit of time. I'm actually going to split this lesson into 2 videos. So those were our 2 basic examples, and on the back of your notes we have 2 more composite examples, and those will be in the next video.